Hello everyone, it's August the 2nd. Alright, let's try this one first. Today's challenge. My calendar. You're implementing a program to use as your calendar. We can add a new event if adding the event will not cause a double booking. Double booking happens when two events have some non-empty intersection. The event can be represented as a pair of integers, start and end. It represents a booking on the half-open interval. The range of real numbers x such that, implementing this class, book return true if event can be added to the calendar without causing a double booking, otherwise return false. Okay, so basically we just want to check whether something can be inserted. Like this is false because 15 is in between. What data structure should be used for this? I mean, this is just the intervals, right? And intervals. Man, they're adding the book one by one, so it's different from, let's say, you have all the intervals already, and then you just do binary search. This one, you can't. Right? You can't. You're adding a one by one. So, and this is also have an order, like 10, 20, if I add that. And then I add 15, 25, and then that's a no-go. So whatever is being added is going to be good. And whatever new thing come in, so we're saying we can always, nah, that's not true. I can have a small, I can have one at the very beginning and one at the very end, and everything can be added in the middle, right? What you gonna do about that? What else can we say? We have a range, and then we have a next range. We want to check, right? Say we have some range that's non-overlapping already, and we want to add a new one. Then we want to check whether the new one. How about dictionaries? Yeah, dictionaries. I mean, at most 1,000 calls. So that's kind of a hint that we can use pretty stupid method for this, right? Let's say we have we have a dictionary where the key is start, the value is end. Ooh. So start and end, right? Start and end, start and end. And we can, every single time, just call a sort function on this. Because only 1,000 calls, okay? We call a sort function, and then we can binary search. You know what? If it's 1,000 call, we probably can just iterate through all the start. All right, we just iterate through all the starts. And if the start is larger than my current end, then there's we start from the first, right? And we go one by one, and we compare to my current start, right? Maybe binary current start. You know what? That does not guarantee, right? That does not guarantee. So what would be the better way? So we have some range, and I want to add a new range, right? So to add a new range, I need to know if I am in between. So if I am larger, if some start is bigger than me, then we have to consider that. But anyway, so the point is, I need to make sure that I am in between. So if I have a start, and start, right? And I have my start. And I have some starts, so I will have to go in between. So yeah, maybe we can just do a binary search, right? I need to go between two starts, right? So that's where potential I can be. because I have a start and end and start and end, and then my start is in between the two, so that's where I need to be, because I cannot be later. Okay, so we can binary search. We sort it by binary search to find where it should be. If it's at the end, we still cannot add it. If that's at the beginning, we cannot add it. So no matter what, we cannot add it. So we look for the index, and then we need to compare the one in front of me and compare the one behind me. So the one in front of me, and I compare its end. The one behind me, and I compare my end. And if it's good, yeah, so 1,000 times, each time O1 log n. I guess, because only 1,000 calls. I don't know if there's any better solution than this. We need, doesn't matter which one, self dot calendar, the cal is a dictionary, right? If not, self.cal start equals end, okay, and then return true. Otherwise, starts equals sorted self.cal, and then index equals start bisect right starts and start, right? So we give an index, and then we say what if they're the same? Well, if they're the same on the start, that will be double booking, right? But I didn't say if so. Yeah, I think if the start is the same, that will be double booking. So if they're the same, we will return something. So if it's a 0, then if index is 0, then we're fine, right? If index is 0, then we don't have to compare the things before me. So we say if index is equal to is not equal to 0 and starts index -1, that's the previous start. I was trying to find a case where we can reject. So it could be the previous is long. So its end must be smaller than my end. Right, hold on. So this is start to end. And I am here. So its end, so we say self calendar. This is the previous one, right? So that end must be smaller or equal to, or we can say if it's larger than end, then we return false, right? So if index is 0, then it's fine, we don't have a previous one. If index is not 0, then we can go the previous one and we check its end. If its end is, actually that's not end, it's larger than start. The previous one's end is larger than my current start. It's equal to, that's fine. But if it's larger than my start, then it's a no-go. Okay, so that's one. Let me say if index is smaller Yeah, actually it's larger than 0. If it's smaller than len starts. Oh, actually no, if it's equal to len starts. If it's equal to len start, that means we always can, we can always do -1. No, we want to do index by itself. So we say if this is smaller than, what if it's equal to n minus 1? It cannot, it can be n minus 1. Yeah, it's fine. If it's smaller and starts index because it's going next one, right? So if this is a start is smaller or equal to my end, right? So it means the next start is smaller or equal to my end. Actually, equal to n is also fine, right? If it's small, if it's equal to my end, that's actually fine. But if it's smaller, then we say return false. Otherwise, then I say if it's equal to. If it's equal to, that means the start is fine. We just need to compare the n, and the n is already compared. So then we say self.cal start end and return true. Okay. So now the problem is just whether this is fast enough. That I don't know. Yeah, 1000. I feel like it should be. Just overlog in every single time. Let's try this. And it passed. But look at this. I think there is a much better solution than this. So $7.29. O1 login per book call. Not the most efficient, for sure. So apparently there is a better solution. Look at this one, 200 something. So let's see if we can push a little bit. 10 to the 9th. We are pushing the range. Now we have a new range coming. Add. Yeah, how do I insert in the middle? I have no clue. I take a look. What was the first method I had? Let's say, oh, 108 test cases. 107. I removed the one test case. Oh, let's peek. Let's peek. An array. O squared. Are you kidding me? It's inserting. This is inserting. What? Come on, man. This is inserting. I sort every time. This is insert every time. You're telling me this is faster than the sorting method? I cannot believe it. This is just a loop through the entire thing. This is not working. Seriously. I don't know, man. How could it just be inserting? How could it just be inserting? That's so bad. So what are the solutions? Insert? Come on. Oh, balanced tree. I think that is the one that they're looking for. Balanced tree. O and log n. It's a binary search tree. Yeah. Sorted containers. I don't think you can use that. That's like cheating. Nah, they say this is just a binary search tree. This is a binary tree, right? And I would just insert. Right? I say if its start is larger than or equal to, so each node we have a left and right. If the start is larger than the end, insert will create a node already. Will this be faster? Let's try. That's not binary search. That's not balanced tree. That's just a binary search tree. That's it. Depending on the input test cases. So this is a binary search tree solution. Best case is O n log n. Worst case is O n squared. And this is always O n log n. Right? This is n log n to sort, and then log n to do this. So why do you even want to do a binary search tree? Just for fun. Practice. I like to call it tree node, right? And the way I like to do it is call left and right, both are integers. Self dot. Oh, I cannot say left and right. Low and high. Because I need self dot low equals low, self dot high equals high, and self dot left equals none, self dot right equals none. That's it. Okay. And then self dot root is none, and def insert. Insert. We want to insert a range to a node, right? We want to insert a range to a node. So we have a node. Hold on, this is a node. And then we want to insert a range to this node. Yes. And we have tree node, probably optional it, right? And then low and high. This is kind of range. Return Boolean value. If not, node. It has to go from node to insert. No, I don't think this will be this. This will always this. Okay. So node to insert, right? Node we have a range. We just say if low is larger or equal to node dot high, right? We say if not, if node dot right is none, then node dot right equals tree node low high, and then return true. Else return self dot insert node dot right low and high. If high is smaller equal to node dot low, right? Then if node dot left is none, node dot left equals tree node low and high. Turn true. Else when it returns self dot insert node dot left, so node dot left insert low and high. If neither, then return false. So book, we say if self dot root is none, self dot root equals tree node start and end. Return true. Otherwise, return self dot insert self.root, start, and end. Alright, let's try this. Binary search tree. See if it works. I think this will be faster, honestly. Oh, of course it does not, because I haven't passed it into this. Yep, maybe it is faster. Huh? I am surprised. It is faster. Faster than sorting. That means, okay, so it's a much better runtime than sorting and a binary search, which means the input is pretty balanced already. All right, so that's that. Done with this. All right, how long do you want to tackle this? I mean, we already know. Let's do this. So we need a number of rows, and I don't know. I mean, I don't feel like doing. It's kind of, you know what? I just save this for. Hold on, I cannot. This is a new thing. Oh man, can't open a new one. Gotta be kidding me, man. Yep, can't. I want to do this some other time, honestly. Needs a large chunk of time to really calm down to do this. I should save all the difficult questions. I mean, I can save all the difficult questions. Save for weekend or just not that late. I don't know. Just don't feel like doing it. Ugh, this is a difficult one. All right, let's try this one. Rearrange characters. To make target string. Given two zero-indexed strings, you can take some letters from S and then rearrange them to form new strings. Return the maximum number of copies of target that can be formed by taking letters from S and then rearranging them. Some letters, rearrange them to form new strings. Well, the first thing in my mind is a counter. And it cannot be repeat, right? So a counter, and we just compute. So one counter, two counter, and then go through this, and then go through this, right? And we just do a divide, right? Let's say that we have once, but just have like say 3 times. So we have 3, and I would take the minimum. Okay. We'll skip it. Yeah, it's fine, I guess. I mean, I can do whatever I want. Just sometimes gotta push. Sometimes, yeah, I just don't feel like it. I don't feel like it. Okay, so we say CS, CT, S, target, and then first equal to math.inf, that's how many we can have, and then for letter and count in ct.items, right? Res shall equal to minimum res cs letter divided by count, and then return res. So this shall be 2, this shall be 1. As target. Math is not defined. In the edge cases, we always have a length. Yeah, I think this should be fine. Okay. O(n), I'll call it n plus n. I read something about Python profiling to make it faster. It's actually quite interesting. The majority of the time, like that's the question of counting word frequency in a giant file. And of course, the slowest will be taken, and then we're thinking about the file, it's so big that it's impossible to load the entire thing in your memory. So you have to read it like line by line, chunk by chunk. And in Python, if you do it naively, line by line, and we have tons of lines, then the slowest part is the script itself, the looping. The looping is very slow. So in Python, you should not loop. The optimized way is to read in large chunks. So instead of one line, which usually a couple kilobytes, you read hundreds of kilobytes at a time. So the read itself is in C, so it's fast, and the split, the tokenization is all in C. So the only thing that's not in C is the looping part. So if you reduce the number of loop, then you speed it up. So from that article, when you do that, we can speed up the process twice, 2 times. You got 2 times performance boost. But of course, Python is still one of the slowest, but at the same time, also one of the easiest to write. So there's always a balance. And then when you go to the C++ code or C code, and you see it's so long. I think the C is what, 150 lines, but the lightning fast. Like Python is like 1 point something seconds, 1.13, I think, or maybe 1.31, I forgot. And really fast one can go to point something, 0.4, 0.5 seconds. That's giant, right? It's like 2 times, 3 times faster than Python. Anyway, people don't like this one. Apply discount to price. A sentence is a string of single-space separated words where each word can contain digits, lowercase letters, and a dollar sign. A word represents a price if it is a sequence of digits preceded by a dollar sign. For example, blah 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 represent prices where this, while this do not. You're given a string sentence representing a sentence and an integer discount. For each word representing a price, apply a discount of percent discount percent on the price, and update the word in the sentence. All updated prices should be represented with exactly 2 decimal spaces. Return the string representing the modified. All prices will contain most 10 digits. Why do people don't like it? I think it's an interesting problem. This tokenization. All right, how are you going to parse it? Well, we can. I'm thinking about replace, regex. Regex. Ooh, this is actually very interesting, regex. So it has to be single space. So it has to, yeah, okay. Oh, what if the dollar sign's at the start? I think the dollar sign at the start is also valid. Let's say like this. I think it's valid. Yep, it's valid. This has to go to the library. So Python re. I still remember the joke. You decide to use regex, you encounter a problem, and you decide to use regex. Now you have 2 problems. Where is the substitute? Wait, where is the substitution? Read the purge. Sub here. Sub pattern. The replacement. Return the string obtained by replacing the leftmost non-overlapping occurrences of patterning string by the replacement. If the pattern isn't found, string is returned. It can be a string or function. If it is a string, any backlash escapes are processed. The pattern may be a string or a pattern object. Okay. Can I obtain the thing to be... Yeah, look at this. It's a match object. Okay, I think I can use this, but we need to practice this. So a match object. Lordy. So import re dot m equals, okay, hold on, s equal to, where's my sentence? No, this is booking shows. This is the one I don't want to do. Okay, so we have this, right? And so m equals a red is a search match, right? Match what? No, it's in pattern first. $, and then have to have either the start or $, and then this one or more, and then either this or and, okay, s m dot, wait, nothing? Oh no, I know why people don't like this one. Basically, it's a test of a regex. Okay, how does this one not work? Wait, no, hold on. Why is this thing not working? I'm not sure. This is to match a single not present. Oh. No. This is not what I want. How do we match beginning? Or actually, I don't know. What's the regex to match beginning? Or like, does this make any sense? Second alternative. This one looks more promising. Say this. Oh no, we have a $. Oh, $. And then we say either this or this. Let's see. First alternative is this position. Second alternative, actually, we are going to match this. Oopsie doozy. That ain't work. Maybe we have to use a group. I think a group works. Oh, we can do this. Group it. First caption group. Either this or the second caption group is this. Third caption group. Oh, I should not do that. Just the front. There we go. And if we have, let's say, another one, we'll match it. Because as long as it has something in the front. But what if I have something like this? Oh yeah, it won't match because to match it has to have a space in front. So if I have something, but then this one will still match, right? Yeah, I match this, what? That's a good question. That's a good question. I need a double check. What if we do this? Does the first one gets matched? It does not. then we have to match, right? We have to match another this or this. Then this one match the first one, this one match, then this one doesn't match. But if we do this, then this one also doesn't match because it's already being matched. Can I match it twice? Look, oh, we don't consume it. We do not consume it. Look ahead. And negative look ahead and look behind. Okay, I think it's look ahead and look behind. Because when you do look ahead and look behind, it doesn't consume the things that you're matching. And that's exactly what we want. So we're going to do look ahead. We say this equals, let's see, positive look ahead. First alternative, second alternative. And then we're going to have a positive look behind. I forgot, it's this, right? There we go. Positive look behind. And then in this case, if we do this, then this will not get matched. Okay, so that is our pattern. Let's change the pattern to this. Oh, what? Fixed with pattern. Yo, man. Come on, man. What? I can't use. Oh, shoot. I think this one has. Oh, I forgot Python. Dang. I don't know. I'm just going through and trying to see. So Java works. So we can use Java. JavaScript. JavaScript works. So we can use a different language for this. But screw you, man. Okay. Now what? How to? That's a good question. Yeah, I have this. There's a regex? Wait. There's a regex? I don't see a regex. What are you talking about? That's a different module. Nah, this is not a... No, we don't want this. We don't want this. What else can you offer me? The hell is this? Something or this. Oh, we need to split. So this means we just split. We say, well, match. Wait, hold on. Something or something, right? So we'll match something or something. What's the first something is we'll match this or match this. And then how is the end? So you just look behind doesn't work, but look ahead allows. Yo, you tripping, man. You tripping. Really? So look, damn. So look behind does not allow, but look ahead allows. How does that even make any sense? I thought they would be the same. Wait. I think I also have... I got none again. What the hell? I'm supposed to match 3 things. I don't know, man. R? No. What? Gosh. It's not... So, don't call match? Oh, search. So I have to call search. Yeah, why do you even provide a match? The only match is 1. The hell? Oh, isn't that a match all, or is that match all? No, search. Find all. Yeah. Find all. And the previous is this, so it doesn't work. Let's also check this. Okay. Then that's not a match object. Wait, hold on. That's fine. So this is the right one, but now we need to do sub. Right? We need to do sub. So def match obj. Okay. Then we say ooh, all I need is just to get the $sign out. So I can just match the character. And then I can just say val shall equal to match object dot group, maybe 1. Okay. Yo, I actually don't know. No, it's not final. Let's just go match search, and will be this and the $sign, and we're gonna match just this thing. Okay. And then m dot group as match object 0 1. Wait, why group 0 is huh? Why group 0 is 1? Wait, I don't understand. No such group. Why group 0 is 1? I don't know. So group 0 is 1. I would imagine group 0 is this thing. And group 1, I should say group. Group 0 is the entire match. Oh, I see. Because the previous one will match empty or match. Okay, I see. So we have to use group 2 actually, because that's the second match, right? Group 2. Okay, so def REPL match object val equal to m dot group 2, and then what? Return a value. Okay, so this is the value. Actually, we can just, is that integer or it's floated, and return. Then we can f string this thing. Val divided by that's 0.5, right? And then I think it's 2f. Nah, apparently this is not right. I never remember. Oh, this one's good. Python f string 2 decimal places. Something 2f, like that. But I forgot. Like, I have to check this every single time. Don't round it. Don't round this to me. Dot 2f. Dot 2f. No. Colon dot 2. That colon dot 2. Actually, I don't think that's. Oh, this is not what I want. Colon dot 2f. Colon dot 2f. Colon dot 2f. Okay, so we have the replacement. Then we do s is this re dot sub. Okay, so we'll go into the pattern first. Pattern is this thing. This is the pattern. So pattern and this is the function and s. What the heck? Oh, should we put it inside? You dumb. So dumb. Let's put it inside. He doesn't like it. Unterminated string. How is that unterminated string? There we go. Okay. Wait, the first one is not captured. What? This is a little bit tough to do, like all here. Yeah, I feel you guys. Feel ya. So this is what I have. Discount 100. Actually, let's do 33. Now, what I want is to do red.sub pattern placement sentence. So return. Right. Okay. Now you kind of feel the other one's actually easier than this. So we got 1.7, but the first is skipped. It didn't match the first one. Oh, shoot. It has to be this. Then why don't we match this here? Right, we have to match this anyway. If we match it before, we have to put it, yeah, if we put it here, then you match, then where the dollar sign go? That didn't match it. Oh, 100 minus discount. Dollar sign. Because I matched this, but I don't match things in front. There we go. That's the one. So probably I can just do it in one line. I say placed value equals this thing, float this times this divide, and then we say rep. Yep. Okay. Indeed, right? You use regex, then you have two problems. But how do you do this without regex? It's a regex problem. I don't think you can do this without regex. Let's see if we pass. This one definitely pass. We have edge case, edge case, edge case. Oh, we pass. Ooh, ooh. Feel very lucky. Once you use regex, now you have two problems. Regex is not easy. Regex is not easy. Trial and error. Lots of trial and error on regex101.com. Let's see. When people don't like it, just regex practice, right? I mean, what's the purpose? Okay, what are the other solutions that you have if not regex? No, I don't think this is stupid. I mean, it's just test regex, right? One pass. They are not testing regex. I mean, can you do it without? Yes, you can. The precision error. Oh. Oh, I see. Oh, precision. Okay. And how do you deal with, and why don't you guys use regex, right? Oh, they split the words and then they check each word. Ah. And then we join it again. Oh, I see why. Set precision. Ah, yeah. I remember this thing. Yes, I remember this thing. Set precision. Oh, wow. People don't like this one. I'll post mine. I like to do it this way. 3 rejects. I think if you use rejects, yeah. There we go. Just post this. If you use reject, now you have 2 problems. All right, that will be it. It was quite fun. It's more fun than doing the hard problem, right? Even though it took a long time, but yeah, it is more fun. All right, that'll be it. I'll see you guys tomorrow. Adios.